For this section, we are going to learn to evaluate logs. These are logs, and they have values that most of these work out nice and neat. This right here is the most important method for changing a log to an exponent, because really that's all a log is. It's a way to find values of exponents. So if I have an exponent, this is the log format of this. And how do you make a log to an exponent and vice versa? Well, what you do, make the log into this, is you drop the log and switch m and n. Okay, so you're going to switch these two. And if you look right here, do you see how m and n, the b is the base, m and n got switched. And that's the basic structure. If I want to go back from an exponent to a log, I put the word log right there and switch n and m. So that structure going back and forth is essential. Now the rest of these we will talk about as we get through these problems. Now, for this problem, how do you find the value of this? But when you see this, what you do is you take the word log off and you switch to 25, and I'm going to put an X right here, something missing. So what this is basically saying is 5 to the what power is 25. It's saying 5 to what power is 25. And then from there you just kind of think about it. 5 to what power is 25? Oh yeah, that's 2. 5 squared is 25. And a lot of these work out nice and neat like that. So when I see this, what I got to think about this is saying 2 to what power is 16. So 2 to what power is 16? That's what it's asking. 2 to what power is 16? That would be 4. Okay, all right. So this one, I want to find out what this is saying. It's saying 5 to what power is 0? So 5 to what power is 0? Okay, so 5 to what power is 0? Well, that's impossible. You can never take 5 and power it to get 0. In order to get 0, you have to multiply by 0. And 5 has no zeros in it. It just doesn't make any sense. So this is, I call it, not possible, or no solution. We can't do that. There's no value to that one. Okay, next one is we're going here. Now, we have to go to one of these formulas here, one of these examples or formulas, basically, yeah, to find this value. Because what happens is, you notice the base is missing? So which one of these has no base? You can see it right here. So when the base is missing, it's telling you that the base is 10. Oh, so can I write a 10 in right there? When the base is missing, the base is 10. So I could just put that there. So this is saying 10 to what power is 10,000? 10 to what power is 10,000? Well, 10 to the first is 10. 10 to the second is 100. There are 4 zeros here, so that is going to be a 4th power. So it's 4. Okay, let's keep going. 8 to the what power is negative 8. Let's write that out. It's easier to see. 8 to the what power is negative 8. Oops, I just messed up. Negative 8. So 8 to what power is negative? That's impossible. I can't take 8 and get a negative out if everything if I'm doing 8 times 8 times 8 times 8. I mean, it just doesn't make any sense. I could get a negative 8 out of that if I power. So this is another not possible. Now, something you're going to notice. If you ever have a 0 or a negative in a log, you're going to notice it's always going to be not possible, because you cannot take a log of a 0 or negative value. It's kind of like a square root. Can't square root a negative. Logs can't have negatives inside or zeros, so there's an extra 0 is not possible either. With a square root, you can square root zeros, but not logs. Okay, so these 5, we converted logs to exponents, then just looked at them to find the value. Now this was a little weird. You have this ln. I haven't had an ln yet. Look right here. You see the ln? When you have ln, it's a log base e. Now what is e? E is a number. E is a number. It's approximately 2.71, and it's in your calculator. You can look it up. You can use the calculator to crunch the number and see it. But e is a natural number that comes about with a lot of exponents when things grow and decay naturally. It's an idea. You kind of learn exactly what it is in calculus, but we're not there yet. So basically, if you see the ln, you're going to need to know it's log base e. So what this one's really saying is this is log base e. E. Now, why are there 2 e's? because e is still inside of the log, the ln, but the base is a e. So if it's ln space e, if it's missing a base, it's base 10. So what is this going to be? Now let's write it as an exponent. This is saying e to the what power is e, and hopefully you can see e to the what power is e. What would be e to the first would be e, so it's 1. Now you could also look at this one. See this one right here? Whenever the base is the same as the what's in the log, or the way you're taking the log of, whenever these are the same, the answer is 1. See? E and e, 1. You can also look at this and know it's 1 because of just the logic of switching to an exponent and looking at it. It would make complete sense. But here's a little shortcut. All right, let's keep going. Look at this one. This is saying 7 to what power is 1 over 49? Well, for that one, 7 to what power is 49? 7 squared is 49. And when it's on the bottom, what you're doing is you're changing this to a negative power. Negative powers drop to the denominator. This little property of negative powers. So with this one, it's going to be negative 2. Again, reminder, 7 squared is 49, and it's negative because it's on the bottom of the fraction. So be careful on that one. Next one, okay, this one's saying, let's see, 5 to what power is 20? And about now you should be scratching your head going, that doesn't make sense. That's some decimal. I couldn't figure that out. So what decimal might that be? Well, let's think. What would it be approximately? Well, 20, let's see, 5 to what power? What's a good number? What's 5 to the first? It's 5. 5 squared is 25, which is close to this. So shouldn't, if the 5 to the first is 5, 5 to the 25, sorry, 5 to the second is 25, isn't it between 1 and 2 and really close to 2? So I would probably think it's somewhere around maybe 1.8, maybe. It's just an approximate. I know it has to be 5 squared to be too far, but 5 to the first is way too small, so it's somewhere in between, closer to 2. Okay, now this one. Okay, so if we can approximate it, it's decimal. So how do you write this answer? Well, you can leave this. That is an okay answer, but if you look up here, you can rewrite any log as, it's called change of base. You can write log m over log b. Log m over log b. You basically make this the top and the base, make a log by itself of the base. You could also use ln. ln m over ln b. Either one works. So this is an okay answer because you can't get the exact value. This is a decimal approximation, just kind of guessing. But other possible answers you need to get used to writing are this. You could write log 20 over log 5. That is an okay answer, and some of your dummy calculators like on a smartphone, this is how you'd find the value. Now you could also do it as ln 20 over ln 5. They both give you the same exact answer. Both are fine. And then, again, these are ways to rewrite logs when you can't find the value easy. Like all of these are easy to do by looking at. This is okay, okay, okay. Just depending on what like a multiple choice answer looks like and what they're going to do. This is about decimal. And how would I get this? Well, if you use, a smartphone or a not so bright calculator that's not so fancy, you would just take this log, divide by this log, and you'd get that number. Or this ln over ln 5 gives you this, about that number, or something like that. So hopefully that helps. It is kind of the weird one, but guess what? This is where most of your logs are going to look like. Most of your logs don't look like these that work out nice. Okay, this last one, base is missing, so I'll put a little 10 there. I'm also going to do something else. I don't like 0.1. Did you know that 0.1 is 1 in the 10th place, or 1/10? Again, 0.1 is 1 in the 10th place, or 1/10. So I want to think of this as, this is saying 10 to the what power is 1/10. Hopefully, again, 0.1 is 1/10, so 10 to the what power is 1/10. And, well, 10 to the first is 10, but it's on the bottom, so it's negative. So this looks like it's going to be -1. So this one's doable. Again, this one in this whole grouping is the only one that's not doable, and this is what most of your answers are going to look like as you get into these, because logs don't always work out nice, unless we prefab them as teachers to be all perfect. Once again, a log. Let's go back to an easy one. This is saying 5 to the what power is 25. If you rewrite this, well, hopefully you can see that's a 2. 5 squared is 25. So what you do is you drop the log off and switch these two. That's how you get that format. If you want log, you want to go back on, you put the word log here and switch these. You'll get used to it, but basically you just want to look at it. 5 to the what power is 25 is what it's saying. Or here, 2 to the what power is 16. Get used to thinking it that way. Also, if it's ln, it's base e. If there's no base, it's base 10. And if both the base and the inside are the same, it's going to be 1. And lastly, answers that don't work out can be rewritten like this. Good luck with this stuff.